I mean, Andrej Karpathy literally built Tesla's autopilot.
Right.
He wrote the foundational code that let cars, actually see the world. He helped found OpenAI.
Yeah, he's essentially one of the core architects of the whole AI revolution.
Exactly. And yet, he recently admitted something that is it's completely counterintuitive.
Oh, the programmer comment.
Yeah. He said he has never felt more behind as a programmer.
Which is just a staggering admission, honestly. I mean, when the person who laid the track for the train tells you the train is moving too fast for him to catch,
Well, you pay attention.
you have to.
Right.
The rest of us need to look really closely at what's actually fueling that engine.
So, okay, let's unpack this today, because we're doing a deep dive into a recent Sequoia Capital conversation with Karpathy. And this realization of his, it points to a fundamental fracturing of what computing even means anymore.
It really does. It's a huge shift.
We're moving from, typing explicit logic to something he calls vibe coding.
Vibe coding, yeah.
And we're watching this massive transition from traditional software engineering to, well, agentic engineering.
Right.
We need to figure out why the AI we're building is not like a smart animal, but more of a summoned ghost. And ultimately, what that distinction means for the survival of human skills. Like, what are we even doing here?
Well, and for anyone listening, I mean, the relevance of this really can't be overstated. We are witnessing the abstraction layer of human interaction with machines moving completely out of the realm of syntax.
Yeah.
Like, think about when the graphical user interface was invented, right? We stopped typing command lines and we started clicking icons.
Right, the GUI changed everything.
Exactly. And what Karpathy is describing is the next tectonic shift. It's moving from clicking and typing to pure semantic intent.
Pure intent. I love that.
Yeah.
So let's start with the catalyst for Karpathy's shift in perspective. This happened just this past December during his holiday break.
Yeah, the December awakening.
Right. So he's been deeply embedded in this space, obviously. He's been using advanced autocomplete tools for a while.
Like Copilot and Claude Code, things like that.
Yeah, exactly. You write a function signature and the model sort of fills in the boilerplate.
Right.
But during his break, he hit a wall with he called it his infinity folder of side projects. And the dynamic just completely changed for him.
Well, because the models crossed a threshold of reliability. For the longest time, generating code with an LLM was this really high-friction process of micromanagement.
Oh, totally.
You prompt the model, it spits out a chunk of Python, and you instantly have to put your editor hat on.
You're hunting for bugs immediately.
Exactly. You're scanning for hallucinated variables, you're fixing off by one errors, correcting the logic path. I mean, it was powerful, sure, but you were still firmly gripping the steering wheel.
But over that break, he stopped correcting.
Right.
He was feeding these models increasingly complex prompts, expecting the usual breakages, and the breakages just stopped happening. The chunks were flawless.
Yeah, they just worked.
So he moved from being this editor to a trustful observer. He just started giving the model the vibe of what he wanted.
Hence, vibe coding.
Right. I want to look at the underlying mechanism of why that happened, though. Because it wasn't just, magic.
No, it was a structural shift. We saw a change in how models allocate compute during inference.
Okay, unpack that a bit.
So instead of just predicting the next token in a purely reactive, linear way, the models started utilizing hidden chains of reasoning.
Like thinking before speaking.
Exactly. They were effectively drafting, testing, and revising their own logic paths in the latent space before they ever output the final code to the user.
Wow.
And this severely reduced those syntax errors that plagued the earlier iterations. So the psychological result for the developer is profound. You transition from being an operator, managing the machine's state, to a director, managing the machine's output.
I mean, I struggle a bit with the director analogy, though. Let's look at it like teaching a teenager to drive.
Okay, yeah.
You don't just suddenly become a director. For months, you are terrified.
Oh, absolutely. Gripping the dashboard.
Right. You're ghost braking from the passenger seat. You're constantly evaluating their spatial awareness. The moment you finally sit back, look out the window, and just trust them to merge onto the highway without your input.
That's a huge shift.
It is. It isn't just a change in their skill. It's a massive psychological leap of faith on your part.
And that leap of faith is exactly the friction point Karpathy identified. Because
No.
a lot of developers tried these tools 12 or, 18 months ago.
Right.
They experienced that micromanagement phase, got frustrated, and basically wrote them off as parlor tricks.
They refuse to get back in the passenger seat.
Exactly. They refused. And what Karpathy is arguing is that if you haven't reevaluated these agentic workflows recently, like very recently, you are driving a manual transmission in a world that has already moved to fully autonomous vehicles.
That's wild. Okay, so that structural shift in how we instruct machines, it brings us to his framework of software evolution.
Yeah.
He breaks this down into 3 distinct eras.
Right, the 1.0, 2.0, 3.0 framework.
Yeah, and I want to spend some time here because the implications are just massive. Let's look at software 1.0.
So software 1.0 is the paradigm we've lived in since basically the dawn of computing. It is strictly deterministic.
Meaning humans write all the rules.
Exactly. A human being translates a real-world problem into a highly brittle, explicit set of logical instructions. It's C, it's Java, it's Python. You are defining every single state the machine can possibly exist in.
And if the machine encounters a state you didn't explicitly predict?
It crashes, it throws a null pointer exception, and it dies.
Right.
The burden of anticipating the entire universe of edge cases falls entirely on the biological brain of the programmer.
Which is exhausting.
Highly exhausting. But Software 2.0 changes that burden.
Wow.
This is the deep learning revolution of the 2010s.
Okay, so the neural net era.
Right. You stop writing explicit logic loops. Instead, you design a neural network architecture, establish a loss function, and feed it massive data sets.
So you're not telling it exactly what to do anymore.
No, the network adjusts its own internal weights through backpropagation. The machine discovers the logic by looking at the data.
Okay, so just to make sure I have this. In 1.0, you write the recipe.
Right.
In 2.0, you give the machine 1,000,000 photos of a cake and the raw ingredients and let it randomly mix them until it statistically converges on the recipe.
That's a really good way to visualize it. But Software 3.0 is where the ground completely gives away.
This is the mind-bending part.
It really is. In Software 3.0, the large language model itself is the computer.
The LLM is the computer.
Yes. The context window is the RAM. And your natural language prompt, your English sentence, is the code.
Hold on, I need to challenge the terminology there a bit.
Yeah.
Calling English text code feels metaphorical, right? Almost poetic. Code actually compiles into machine instructions. How does a paragraph of unstructured text physically act as a compiler?
It acts as a compiler because the LLM maps semantic intent into an executable latent space.
Okay, what does that mean in practice?
Let's think of Karpathy's example with the OpenClaw installation.
Right, the environment setup.
Yeah. Under Software 1.0, deploying software across diverse environments requires an incredibly complex bash script.
Oh, I've seen those. They're nightmares.
Complete nightmares. The script has to query the OS, branch its logic based on the kernel version, check for specific dependencies, manage file paths. It's a massive, sprawling decision tree.
And it's highly brittle. One wrong path, and it fails.
Extremely brittle. But in Software 3.0, the installation script is just a text file that says, in plain English, install OpenClaw on my machine.
That's it. Just the sentence.
That's it. You feed that text into an autonomous agent. And the agent isn't blindly following a decision tree. It opens a terminal. It queries your specific system state. It attempts an installation.
And if it hits an error?
Say it hits a missing library. It doesn't crash. It reads the standard error output, understands that it lacks a dependency, searches for the correct package manager command for your specific OS stinus,
Wow.
installs the dependency, and tries the primary installation again. It is running an active, dynamic debugging loop in real time.
So the agent brings its own localized intelligence to the execution. Instead of the developer pre-packaging the solution to every possible failure, the agent dynamically generates the solution at runtime, based on the specific environment it finds itself in.
Precisely. You are programming with intent, not syntax. The natural language prompt sets the boundary conditions and the goal, and the model's internal geometry calculates the trajectory to get there.
I mean, if that dynamic generation is true, it forces a really uncomfortable realization about the software we use every single day.
Oh, absolutely.
Karpathy talked about his Menugan project, and this completely shifted my perspective on what an application even is. So he was building an app to solve the classic restaurant problem, right? You get a menu, but there are no pictures of the food.
Right, a standard real-world friction point. Everyone's been there.
Yeah, exactly. So he built a classical application first. The user takes a photo of the menu. The app routes that image to an external optical character recognition service, an OCR, to pull the strings of text.
Standard 1.0 pipeline.
Right. It takes those strings, passes them to a back-end server, which formats an API call to an image generation model. The generated images are sent back to the app, which then dynamically renders a brand new user interface to display the food next to the text.
It's a lot of steps.
It's deployed on cloud infrastructure. It has routing, state management. It's a heavy traditional software stack.
And then he realized it was all entirely unnecessary.
They called it spurious because in the software 3.0 paradigm, you bypass all of that middleware.
All of it.
You take the raw photo of the menu, you hand it directly to a multimodal model like Gemini, and you instruct a tool to just overlay generated images onto the blank white space of the original pixels.
Right.
There is no OCR. There is no routing. There's no custom UI rendering.
Yeah.
The model just spits out a modified image.
This is a profound architectural collapse. I mean, Karpathy is pointing out that a massive percentage of the code currently existing in the world is just connective tissue.
The glue.
Yeah, it's glue code designed to translate data between different rigid formats because classical computers can't understand semantic meaning. OCR only exists because a CPU can't look at a pixel and understand that it represents a letter.
But a neural net can.
Exactly. A neural net intrinsically understands the representation.
So all the APIs, all the parsers, all the UI frameworks, they're just scaffolding we built to work around the limitations of von Neumann architecture.
Yes. And Karpathy extrapolated this into a vision for 2026, and beyond that, completely redefines the operating system itself.
The OS as we know it might just vanish.
Right. If neural nets can process raw, unstructured input like video from a camera or audio from a microphone and directly output the desired result, the traditional operating system becomes obsolete.
So what does that look like?
Imagine a device where the neural net is the host process. You don't open a web browser to search for a recipe. The model takes your voice command, retrieves the data, and uses a diffusion model to render a custom ephemeral interface directly onto your screen for the exact 10 seconds you need it, and then it dissolves.
The interface just melts away when you're done.
Exactly. The CPU is relegated to the basement, basically, just handling deterministic math when the neural net asks it to.
I see the vision, but I have to play devil's advocate here. Isn't this just a faster pipeline for the exact same result? We're still just looking at a recipe on a screen, right? Whether it's rendered by HTML and CSS or generated on the fly by a diffusion model, are we really talking about a paradigm shift or just extreme optimization?
No, it is fundamentally a paradigm shift because it unlocks capabilities that were mathematically impossible under classical computing. It isn't just about rendering UI faster, it's about the synthesis of unstructured reality.
Unstructured reality, give me an example of that.
Karpathy used the example of personal knowledge bases.
Yeah.
In the 1.0 world, software only works if data is rigidly structured in a database, right?
Rows and columns.
Right. If you have scattered PDFs, messy text notes, old emails, a classical system can only offer keyword matching.
It can't read them. It's just looking for the string of letters.
Right, it can't understand them. But an LLM maps the semantic relationships within all that noise. It can dynamically compile a bespoke wiki that synthesizes a narrative across 1,000 unstructured documents. It discovers connections that weren't explicitly linked.
Things no human had manually tagged.
Exactly. You couldn't write code to do that 10 years ago because the logic of human language doesn't fit into Boolean operators. We aren't just making the old machine faster, we have built an entirely different kind of engine that processes meaning instead of just numbers.
Okay, so we have this alien engine that can ingest raw reality, understand semantic intent, and render software on the fly.
Yeah.
That sounds omnipotent, but it leads directly to the most glaring paradox in the industry right now. If these models are essentially godlike in their processing power, why are they so incredibly fragile when it comes to basic logic?
The jagged frontier of intelligence.
Exactly. Karpathy brought up the car wash conundrum. You could take a state-of-the-art model, Opus, GPT-4, whatever, and ask it to ingest a 100,000-line code base. It will map the architecture, identify a zero-day security flaw, and rewrite the logic flawlessly. That is elite, genius-level cognitive work.
Truly.
But if you ask that exact same model, I need to go to a car wash that is 50 meters from my house. Should I drive or walk?
The model calculates a distance, recognizes that 50 meters is a trivial walk, and confidently advises you to leave your car at home.
Which completely ignores the physical reality that you need the car to be at the car wash to wash it.
Right.
How does a system possess the capacity to refactor enterprise software but fail a logic test a 4-year-old would pass?
To understand this, we have to look closely at the mechanics of reinforcement learning, or RL.
Okay, right, right, right.
After a model is pre-trained on the internet, it is essentially a chaotic autocomplete engine. To make it useful, labs put it through RL pipelines. The model attempts a task, and an automated grading system gives it a reward for success and a penalty for failure.
Just trial and error at scale.
Over millions of iterations, yes. The model's capabilities in that specific task are heavily optimized.
So the model learns what behaviors yield the highest reward.
Correct. But here is the critical bottleneck. For RL to work at the massive scale required, the grading must be automated. The domain must be strictly verifiable.
Verifiable, meaning there's a clear right or wrong answer.
Yes, math is verifiable. If the model outputs that 2 plus 2 equals 5, a simple script can instantly flag it as incorrect and penalize the model.
Right.
Code is verifiable. The automated system compiles the generated code, runs unit tests, and if it fails, the model gets penalized. Because the labs can run infinite automated RL loops on code and math, the model's capabilities in those specific areas form massive spikes of genius.
But the physical logic of a car wash, how do you write a unit test for that?
You can't, not efficiently. Open-ended reasoning, physical intuition, common sense, these are not strictly verifiable domains in an automated pipeline.
They require human judgment.
And human evaluation is slow and expensive. Therefore, the RL reinforcement in those areas is shallow. The intelligence landscape of the model isn't a flat plateau, it is a jagged mountain range. In verifiable domains, it peaks into the stratosphere. In unverifiable domains, it drops into valleys of shocking incompetence.
This perfectly explains the infamous strawberry problem.
Oh, yeah.
For the longest time, the most advanced models in the world couldn't tell you how many R's were in the word strawberry. People mocked it, assuming the AI was just stupid.
It wasn't stupid, it was blind to the architecture of the prompt. Models don't see letters, they see tokens, which are mathematical representations of chunks of text. Asking it to count letters inside a token is like asking you to count the individual threads in a sweater from across the room.
Right, you just see the sweater.
Exactly. It wasn't a heavily reinforced task because it didn't map cleanly to the automated RL objectives the labs prioritized.
And Karpathy contrasted that failure with the sudden leap in chess capabilities between GPT 3.5 and GPT 4. The model didn't suddenly develop a generalized understanding of spatial strategy.
No, not at all.
The lab simply dumped massive quantities of chess game notation into the pre-training data, and chess is a highly verifiable domain.
The takeaway here is vital for anyone using these tools. You are entirely at the mercy of the training distribution. If your workload aligns with the RL circuits the labs prioritized, like software generation or data synthesis, you will feel like you are wielding magic.
But the moment you drift outside that zone,
The moment your workload drifts outside that verifiable optimization zone, you will crash spectacularly into the car wash logic gap.
and that jaggedness forces us to confront how we conceptualize these entities in the first place. We desperately want to anthropomorphize them.
We really do. It's human nature.
If a dog can figure out how to open a door, we assume it has the baseline common sense not to walk into a campfire.
Right.
We assume a unified floor of intelligence. But Karpathy makes a very explicit, unsettling distinction. He says, we are not building animals. We are summoning ghosts.
It's a chilling analogy, but mechanically, it is the most accurate way to frame an LLM. Animals, biological creatures, possess traits forged by billions of years of physical evolution.
Right?
They have intrinsic motivation. A dog explores a room because it has curiosity. It avoids pain because it has a biological imperative to survive. It understands gravity because falling damages its physical structure.
Biological entities operate on homeostasis. They react to the physical world to maintain their internal equilibrium.
Exactly. AI models have zero evolutionary history. They do not have a physical body. They do not experience time. They have no intrinsic curiosity. And they possess absolutely no survival instinct.
They're just math.
They are massive, multidimensional statistical manifolds bolted onto reward circuits. They are predicting the probabilistic distribution of language. They are ghosts simulating reality based on the shadows left on the internet.
I want to dig into how this simulation actually plays out in human interaction, because I see developers fall into this trap constantly.
Yeah.
If an engineer gets frustrated with an LLM spitting out bad code, they will literally type in all caps, "No, this is wrong, fix it immediately."
Ah, the illusion of biological feedback.
Yes. If you yell at a dog, the dog processes your tone, your volume, the aggressive posture. It registers fear or submission. It actually alters its internal state to appease the pack leader.
Mhm.
But when you yell in all caps at an LLM, the model does not feel fear. It doesn't care that you were angry.
It cannot care.
What it actually does is analyze the text string, recognize the statistical markers of an angry human user, likely pulling from millions of toxic forum arguments in its training data.
Right, Reddit threads and Stack Overflow.
Exactly, and it statistically simulates the most probable text string an entity would generate in response to an angry user. It might output a groveling apology, but the apology is synthetic. It is a statistical mirage.
The reason this framing is so critical is that it governs trust. If you interact with an AI as if it were a smart animal or a junior human colleague, you will inherently trust its common sense. You will hand it a complex architectural task and walk away, assuming it won't make a catastrophic basic error.
And then you return to find it told the user to walk 50 meters to the car wash without their car.
Precisely. You have to treat the model as an alien artifact. It is a tool of immense power that requires relentless skepticism, persistent verification, and a deep understanding of its jagged failure modes.
So if the model is a fallible, jagged ghost that requires constant suspicion, how on earth are we supposed to use this to build robust, secure systems?
Yeah, that's the multi-million-dollar question.
How are the professionals achieving these massive speed-ups without the entire software ecosystem collapsing into a buggy, hallucinated mess?
That is the core challenge of the current era, and it leads to Karpathy's distinction between vibe coding and agentic engineering. This is really a conversation about the death of the traditional 10x engineer.
Okay, let's draw the line between those two concepts. We established that vibe coding is interacting with the model via natural language intent. It's highly accessible.
Right. Vibe coding democratizes creation. It raises the floor. A marketer, a designer, or a writer with zero background in computer science can now spin up a functional web application by having a conversation with an LLM. The friction of entry has dropped to basically zero.
Which is amazing.
It is, but raising the floor of accessibility does not automatically raise the ceiling of quality.
Because building a novelty to-do app is very different from building enterprise infrastructure. If you vibe code a fintech platform and the ghost hallucinates a cryptographic protocol, you've just exposed a massive vulnerability.
And that is where agentic engineering takes over. Agentic engineering is the discipline of preserving the ceiling.
Preserving the ceiling, right?
It is the highly rigorous methodology of orchestrating these spiky, unpredictable models to operate autonomously while mathematically ensuring they do not introduce fatal errors.
It's building the guardrails for the ghost.
It's building a localized ecosystem of checks and balances. An agentic engineer doesn't just ask one model to write the whole code base. They architect a multi-agent system.
Right.
Yeah. Agent A is instructed to draft the code. Agent B is given a strict system prompt to act as an adversarial security auditor, reviewing Agent A's output for injection vulnerabilities.
Just attacking it.
Right. Agent C is responsible for writing comprehensive unit tests. Agent D executes the code in a sandbox environment and feeds the standard error output back to Agent A for revision.
You are building a synthetic software company inside the latent space.
Exactly. You are managing the flow of context, handling the memory constraints between the agents, and designing the debugging loops.
Karpathy laid out an incredible vision for how this shifts the hiring paradigm. The traditional technical interview where you stand at a whiteboard and try to reverse a binary tree from memory.
Yeah, leak code style.
Right. He said that's completely dead.
Because it measures a skill that is no longer the bottleneck.
Exactly. Karpathy suggested that the new interview will be an arena. You sit the candidate down and say, build a secure, scalable Twitter clone. You have access to whatever agent swarms you want to orchestrate. Build it and deploy it. And the real test begins once it's live.
The swarm attack.
Right. The interviewer unleashes a swarm of specialized adversarial AI models designed to hammer the candidate's architecture, looking for any edge case or vulnerability to exploit.
It is an automated stress test of the candidate's strategic design. If the system holds under the AI assault, the candidate gets the job. It evaluates architectural robustness rather than syntax recall.
And this completely shatters the myth of the 10x engineer. Silicon Valley has worshipped this idea for decades, the mythical coder who can output 10 times the value of an average developer. But Karpathy noted that when you master agentic engineering, the multiplier isn't 10x.
The multiplier is orders of magnitude higher. A single engineer orchestrating a specialized swarm of agents is no longer laying bricks at human speed. They are commanding a fleet of robotic bricklayers. They can test 100 architectural variations in the time it used to take to compile one. The output potential of a single human mind has skyrocketed.
Which naturally forces a very existential question for developers.
Yeah.
If the agent swarm is writing the syntax, auditing the security, compiling the test, and deploying the infrastructure. What is the human actually doing?
Yeah.
If the machine is executing at 100x, where does the human add value?
Karpathy frames this through what we can call the intern paradigm. He views these state-of-the-art models not as senior architects, but as incredibly eager, mathematically brilliant, but functionally naive interns.
Naive interns.
They have photographic recall of every technical manual ever written, but they lack the contextual nuance of lived reality.
He gave a hilarious example of this from his Manugan project that perfectly illustrates the blind spot. In the app, users have to authenticate, so he used a standard Google login integration. But to manage the credits for the image generation, he used Stripe. The intern, the AI agent he was using to build the backend logic, needed to link the payment identity to the user identity.
A standard database relations task.
Right, so what does the intern do? It looks at the Google payload and sees an email address string. It looks at the Stripe payload and sees an email address string. And it writes logic that says, if string A matches string B, link the accounts.
Because to a statistical engine, that is the most efficient logical path to connect two nodes.
But any human being who has existed on the internet for more than a week knows that is a catastrophic architectural failure.
Oh, absolutely.
People constantly use different email addresses for different services. I might use my personal Gmail to log into the app, but my corporate email is attached to my Stripe account. The intern completely failed to realize that the architecture required the generation of a unique, persistent user ID under the hood to decouple the identity from the surface-level email strings.
The intern lacks the systemic context of human behavior, and this is exactly where human taste, judgment, and fundamental knowledge become the primary bottleneck.
It doesn't see the big picture.
The AI doesn't understand why a persistent ID matters for database integrity over a 5-year lifecycle. It just sees two matching strings and optimizes for the immediate token generation.
So the human role shifts entirely to defining the constraints and maintaining the systemic logic. Karpathy was very clear about what we can safely forget and what we absolutely must retain.
Yes. You surrender the rote memorization, you surrender the trivia. Karpathy admitted he no longer wastes biological memory trying to remember the nuanced API differences between libraries like PyTorch and NumPy.
Right, he just lets the model handle it.
He doesn't need to recall if a function requires the argument keep dims or access. The AI intern has perfect recall of the documentation.
But you still have to understand the underlying physics of the machine.
Precisely. You have to understand how memory allocation works. If you are building a data pipeline and the AI decides to indiscriminately copy massive tensor arrays across the system, the human has to look at that architecture and realize, wait, that is going to cause an out-of-memory error when we scale.
Because the intern doesn't know any better.
The intern doesn't inherently care about memory efficiency unless prompted. You have to understand the fundamental principles of database normalization. You are the general contractor writing the blueprint. The intern is just swinging the hammer.
But swinging the hammer is currently a very disjointed process because the intern is being forced to swing a human-sized hammer. Karpathy highlighted a massive structural friction point we are hitting right now. The AI agents are incredibly smart, but they're trying to operate in an environment that was never built for them.
The legacy infrastructure of the internet?
Yes. Karpathy complained about documentation.
Yeah.
He hates that software tutorials are still written in natural language, meant to guide a human through a graphical interface.
Oh, I totally agree with him.
He said, I don't want to read a paragraph telling me to click a drop-down menu, select a setting, and hit save. Just give me the raw text string, the API endpoint, so I can copy-paste it to my agent and let the agent handle it.
This is a signal of a massive upcoming shift toward an agent-native world. For 30 years, the internet has been built as a graphical user interface. It relies on HTML and CSS to render buttons and menus for human eyeballs and human mouse clicks.
But agents don't have eyeballs.
Exactly. They do not have eyeballs. They do not need the aesthetic rendering. They need raw, structured data.
They need the JSON payloads.
Exactly. Karpathy envisions a decomposition of workloads into what he calls sensors and actuators.
Sensors and actuators.
Sensors are the mechanisms agents use to read the digital environment scraping state, monitoring data streams, reading raw text. Actuators are the mechanisms they use to affect the environment, deploying a payload, executing a script, altering a database.
He used Vercel to illustrate the current friction. When he deployed Manugan on Vercel, he had to act as the actuator. He had to manually navigate the Vercel dashboard, click the deployment settings, configure the environment variables, and manage the DNS routing.
So tedious.
But in an agent-native ecosystem, You don't interact with a dashboard. You prompt your local agent to deploy the project. Your agent uses an actuator to communicate directly, via API, with Vercel's agent. They negotiate the configuration parameters synthetically, and the deployment happens autonomously.
We are rapidly accelerating toward a world of proxy representation. The user interface of the future might not be a screen full of apps, it might be a single persistent connection to your agent.
Just talking to your proxy.
As Karpathy noted, the future of scheduling a meeting isn't you sending a calendar link. It is your agent communicating with my agent, negotiating the time zones, finding the availability, and simply updating the database.
The friction of human interface is being systematically removed. We have agents writing the syntax, testing the security, deploying the infrastructure, and negotiating our schedules. The floor of capability is raised for everyone, and the multiplier for the orchestrators is astronomical.
Yeah.
But this brings me to a deeply philosophical hurdle. If the ghosts are running the machine at this level of autonomy, what is the biological utility of the human brain?
That is the ultimate question of the Software 3.0 era, and it leads to Karpathy's final, most profound point regarding the bottleneck of understanding.
He shared a quote that completely reframes our relationship with AI. He said, "You can outsource your thinking, but you can't outsource your understanding."
We have to differentiate between those two verbs. Thinking in this context is the mechanical processing of information.
Right.
An AI can ingest 10,000 pages of dense legal documentation, summarize the key clauses, and cross-reference them with historical case law in 30 seconds. That is outsourced thinking.
Or it can synthesize 100,000 lines of code and deploy a functional application. That is outsourced execution.
But understanding is the biological integration of that information. In order to direct the agent to know what app is actually valuable to build, to know why a specific legal clause matters to your business strategy, the synthesized information must cross the blood-brain barrier.
It has to actually live in your head.
It has to be comprehended by the physical neural pathways of the human operator.
Because if you don't understand the systemic context, like necessity of the unique user ID, with the Google and Stripe integration, you cannot construct the guardrails for the intern.
Precisely. Human bandwidth is the ultimate hard limit on the speed of technological progress. The machine can generate infinite permutations of data, but a human must ultimately comprehend the terrain to point the machine in the right direction.
And Karpathy is applying this directly to how he uses AI. He isn't just using agents to write code, he's using them to force-feed understanding into his own brain.
Which is brilliant.
He uses models to dynamically compile those personal wikis we discussed earlier. He feeds the AI complex research papers and commands it to project the information back to him in varying formats. Socratic dialogues, executive summaries, synthesized data queries, all aggressively optimized to trigger a biological aha moment in his own mind.
He is using the infinite processing power of the machine to act as a hyper-personalized tutor, specifically to widen his own biological bottleneck. Because if your understanding stagnates, your ability to direct the agents degrades, and you become entirely obsolete.
So to summarize this incredibly dense landscape, we are watching the transition from autocomplete to autonomous vibe coding driven by models that can reason at inference time.
Yep.
We are moving from the rigid logic of Software 1.0 to the semantic intent of Software 3.0, rendering massive amounts of middleware completely spurious.
We are learning to orchestrate jagged, ghost-like intelligence, managing brilliant but context-blind interns through the strict discipline of agentic engineering.
We are anticipating an agent-native internet where GUIs dissolve into API-to-API negotiations. And standing at the center of all of this automated velocity is the unyielding bottleneck of human understanding.
It's all on us.
The fundamental knowledge, the architectural taste, the strategic judgment that is the only thing standing between extreme productivity and systemic collapse.
It is a phenomenal recalibration of human value. But, and I want to leave you, the listener, with a hypothetical scenario to interrogate on your own here.
Okay, let's hear it.
We just established that human understanding is the vital director of the machine. And we established that to build that understanding, we are increasingly relying on AI to filter, synthesize, and summarize the infinite noise of the internet.
Using the machine to learn how to direct the machine.
Exactly. So the question is, How long until our supposedly unique, irreplaceable human taste is simply a downstream reflection of the AI's training data?
Oh, wow.
If the AI is deciding which documents to summarize, how to frame the narrative, and what context to highlight, are we truly maintaining our independent understanding? Or are we slowly entering a feedback loop where the machine is subtly directing the very human intuition we rely on to control it?
That is a terrifyingly valid point. If the ghost is defining the parameters of our reality, who is actually holding the steering wheel?
The abstraction layer continues to move.
Well, as the ground continues to shift under our feet, the only defense we have is the exact biological curiosity we've been talking about today. Keep questioning the tools, keep interrogating the context, and whatever you do, do not let your fundamental understanding atrophy. Thanks for diving in with us.